And good evening, everyone who is watching the stream of video arrives on air, and welcome to my pretty rare but still something pretty rare stream, but it's a stream that happens from time to time. My actually DIY slash creative slash building tinkering stream. So I'm a little bit late, and usually I don't really do anything serious on the camera is. Oh god. Okay, more like this. So usually I don't do really any serious important stuff on Saturdays, but this I just need it. So what's the idea? I have a ton of lights for plants. My wife who has a ton of lights for plants. These are standard lights, just with energy efficient on how to say it right, LED lamps. So they do not consume a lot, and there's a ton of them, and they are not like of a special kinds, just classic fixtures, multi-purpose. We specifically use those ones to just make it repurposable. So, and the idea, well, is to make it as easy as possible to move around. They are partially attached to the walls, to the ceilings, but if needed, they can be like unscrewed in some other place. So they have, like, some of them, they have clamps, so they can be clamped, and pretty much standard lights that use standard power, wall power, 220 volts here, 230 to be specific. But there's like 12 of them. There's one window sill in one room, another window sill in another room, a corner in a third room, and a window sill, and then a corner in another room, and then there's shelves, and etc. 12, I think 12 if I counted right. So I want to be able to turn them on and off with just one button. For that, I'm going to build a bunch of try to build a bunch of radio controlled power strips, so they would be controllable per room or per area, and then all of them you should be able to turn on just with one button. Gonna get you. Good evening, welcome. Okay, I'm moving my microphone out of the way. I'm going to try to just make it a little bit more sensitive, just to compensate for okay, it's not loud enough, I think, just to compensate for the distance. Is it loud enough? I hope it is, because the microphone is not going to be close, so it's gonna sound a little bit echoey because it's away, but I don't want to use another microphone. Don't want to use the radio microphone that I have. So since I'm going to be here, so the camera is on a pretty long, how would you even call it? It's not a tripod. It's a adjustable, extendable camera mount that's mounted to the wall. So no matter how I bang on the floor, on the table, do this stuff here, this one is not going to be shaking. But if I just touch it, yeah, but it's mounted to the wall, not to the table. So it's gonna be way more stable than anything on the desk here. So stop shaking. So only start shaking when I actually accidentally touch it or not accidentally touch it. So I thought of it for a very long time how to do it right. So I've been preparing, and the idea is simple. So we use these devices. So that's like basic wireless switch from AliExpress that can actually remember, I think, up to 10 buttons maybe. So enough for us. That's a separate radio wireless switch that sends like signals to turn it to turn it off, to turn it on. So this can be programmed. So it has several modes, basically on off, on off, or on off, on off. So hold down, on off on one button, on one, off on another. So pretty much like this. So what I wanted to do, I wanted to take this, put it in there, just in the strip itself, and yeah. And when I started working on that, I realized that it doesn't fit in there. So the board even, it's not, doesn't really fit, especially with there is like normally a big switch. I found the ones, well, I found it's like very popular model here from Turkey, I think. So I found the ones with big switch here, but with that big switch, the board even won't fit. So I designed and 3D printed a small adapter to use, that you would install like here, and then you would install the another switch, a different type, like here in this adapter. So I'm not going to click it in because it's kind of like it's gonna stay there, but I spent quite some time designing these they are not clamps, how to say, tabs, that technically should just keep it inside. I tested it, it does keep it inside, it's not going to fall out on its own. So, and it's gonna look like this. It's not really that convenient, but these are going to be pretty much out of sight. So why two sides of the button? Because when you use wireless stuff, when you use remote control stuff, you got to have file saves. First of all, you got to be able to turn it off, then you got to be able to turn it on, and then you got to be able to wirelessly control it with this board. So in case this board dies, this switch allows this power strip to function just like normal power strip with a switch. Technically speaking, these are rated for, according to the Chinese manufacturers, 10 amps, which is a little bit insane. I don't think they can do 10 amps at all, like never. So I'm kinda thinking that it would be like 4 amps max. That's what I designed to be printed on this like button holder here. So I've been thinking about this a lot, been planning this project for quite some time. So if something goes right and smoothly, it's because I been planning it for a long time. If something doesn't go our way, that because I didn't think of it. So the board got to be somewhere around here like this. Already there's a problem that I didn't think of. These small thingies here, that are in the way. So let's cut them. Let's try to cut them just like that. So the board already is pre-wired, of course, because it was in this pretty much enclosure, and I don't like these wires, so we'll have to remove them. Okay, this is gonna be a bit harder. So let's see if the board fits now. It's a little bit blown out, but yeah, okay. Okay, the board now perfectly fits. So, because the board is not supposed to be mounted to anything, it's supposed to be held in this enclosure. Unfortunately, it doesn't have any holes, so for now, I'm just going to use, guess what? That hot glue. But my hot glue gun is like annoying, so I probably will do it off stream. It has a pretty short cable, and I always end up just dropping it from my desk with its pretty short power cable. So, okay, the board now fits. Of course, we'll need completely different wiring here, and these wires, I don't like them, so let's just remove them. Let's start with that. I'm going to need my short hand. I always try to avoid using the short hand, and I always need it when you work with the boards. There's no way around it. So should be pretty well visible. Well, not for that camera. Okay, only for the top cam. It looks like it's like lead-free solder here. Which is annoying to melt. But this is Chinese, so maybe not lead-free. So these wires, they are like super thick for this device. So the wires may be rated for 10 amps, but the relay here, it won't be able, on this board, it won't be able to switch 10 amps reliably for like any amount of time. So okay, let's see if we can make holes in here. No, we cannot, of course. That I use soldering wick to get the holes back. Actually, maybe like this. Desoldering wick, I suppose. Okay. It's moving like insane. Okay. There's an antenna over there, so got to be careful with that. So let's see how fast I can do it. Because there's technically some solder joint, some crimped connectors here, and the main thing is about just fitting everything inside. So I'm not clearing the holes, which is annoying. There's a ton of solder in there, and I'm overheating the board, which I don't like. It's not probably the board you should overheat. Okay, it's twisting, it's turning, it's moving, so gotta try to fix it properly there. Oops, this one doesn't have tubing on its end, so I might scratch the board like that. Okay, and I would prefer it to be lower to touch the desk like this. Opening these holes, it's always the most annoying part. Okay, but it works if you just remove all the excessive solder floating in them. Now I hope you can see that there's a hole now. Perfect. Okay, got them all. Let me open the window. It's not like I need like special something for ventilation here or extractor. It should be good enough without that. Okay, so this is ready now, more or less. Good. The holes are open. So the board's clearly marked here, in and out. Since that's what we have as our wall outlets here, so there's no difference really here between the phase and neutral. There's only difference like between ground phase and neutral. You can insert the plug anyway, so you might end up with phase on one side of it, on one wire in the cable, and neutral on another, or the other way around, so it can be changed. If it can be changed, then there's like pretty much no difference should be for the devices. There's like almost no devices that would be sensitive for the on which wire, which way the phase would come in. So that's how it is. The prongs of the plugs are the same. The holes for them are the same. So at least for this type of, sorry, that was my microphone. For this type of wall outlet, it's the most common one now. European, it's called here. So let's see. So perfectly fits in here, very well. So that's how it's supposed to be then, like this. Gotta be careful. Already caught a problem here. This kinda goes into the relay. So where you mount it inside, so you got to mount it as close to this edge as possible, to this side, to prevent it bumping into this. This is actually the, how to call it right, the wall outlets themselves. The contraption that is actually the power strip itself, that transfers all the electricity. So another thing we got to be aware of, this one here. This is the ground cable, earth ground. So the cable, so it's like this. The cable goes in here. One goes straight to this one. So we probably should give it some length and make it go around like this. Then the interesting things start. The neutral and the phase, they come into the device and they connect to these two prongs here, to these two pins. So it's very convenient that the buttons that I found that actually fit, that actually have two positions on, two on positions, they have this type of connectors on them. So I actually can, I have a crimper, I have the connectors, so I would, for this one, I would just crimp everything. That's how it's supposed to be for when you're dealing with wall outlet voltage, with wall outlet voltages. You do not solder it, you crimp it, you clamp it, you screw it, just to avoid when things get hot. They're not supposed to get hot in here, absolutely not supposed. The whole device will probably break before it gets too hot, but in case you are doing something that can sustain, can survive high currents, if it gets hot, it shouldn't get unsoldered on its own. That's why no soldering for the high voltage, like 220, 120 or 110 wires. Only screwing them, twisting them together, clamping them, and crimping them. So okay, so this is gonna be a little bit hard in terms of planning the length. Oh god. So maybe let's start with the cable coming in. So I have just a piece of cable that I cut to the length, a piece of cable. So, and it's, I suppose, going to be like, it comes in here, then maybe goes around like this. So the length of it, we need to strip just enough. I know people usually just strip a ton and then cut the wires themselves. Where's the knife? Here it is. Here's the knife. So, and I prefer to strip just the amount I need, carefully, very carefully cutting the cable like this, without pressure, without moving it back and forth, just kind of rolling it around the cable to avoid cutting the insulation inside. It takes time, but you're not tearing anything apart. So I have like a proper tool for stripping this type of cables, and I would use it for this type of wires, cables, whatever, and I would use it in case I had to do like electricity in an apartment with a lot of cable stripping and whatnot. But this I want to do like super clean, because that tool tends to tear things apart sometimes a little bit, especially when just stripping individual wires inside this cable. Oh, come on. There's one here. Here we go. So let's see. So these two, they so it's a little bit upside down. So let's make it upside down then. It's going to be like this. These two, the neutral and face, they go over there. And this one should like go around. And plug in there. So let's cut it to the length. Again, everything, I'm planning everything to be like of the right length. One of this to use as a prank. Yeah, this is not smart home, nothing like that. I absolutely would hate to have them like connected into any servers, any internet, anything like that, because they're supposed to work whatever, and they're not supposed to be turned on completely remotely, only wirelessly. So remotely in that meaning that you don't have to be next to them. So welcome, Willy. Hope everything is amazing. Haven't seen you in a while. So, and these are, by the way, better wires than the ones that I just desoldered. So let's put a crimping, what would you call it? Crimped. It's not a connector. It's like sheath of sorts. But since I have them and I have the crimper, I put them on always now these days. So how do you call these? I keep forgetting the name. Here we go. Let's see if it fits, because we are so tight in here that it might not actually. So let's see. This can be just removed from the case. Jack, good evening, welcome. So how much space do we have in there? Okay, we don't have much, so we probably gotta cut this a little bit shorter, which is something I would totally do to save a couple meals. So like this. Let's see. Yeah, that's held in there. So, and if we put it like this, then there is just this loop that goes around, supposed to go around everything, which is something that I would like to have. Okay. This is a clamp for the coming in cable to prevent it from moving. So it's like this. Let's see if it really, the clamp keeps this thin cable in place. So this is not supposed to work with any high loads. So let's say I printed 4 amp max here, but I think the overall load on this power strip is not going to exceed more than 50 watts. So because each light is not more than like 50 watts, and each light not more than like 50 watts. 15, come on. So 45 in total it would be max. Okay, let's see if it stays in there. No, it's not. Crap. That's bad. Okay, we have to make it a little bit thinner. Thicker. I know how exactly. For this I'm ready. So it's just a test. It was just a test. So and let's free it. So this goes. This goes. This goes. Okay, got to make it a little bit thicker. Yellow. Yeah, cut the yellow one. So it's yellow-green, by the way. So it's the ground. Let me just put it on the table. And let me make it a little bit more thick. For it to be able to be clamped properly in this clamper. For that, I'm going to use a bunch of thermal shrinks, tubing, yeah, like this. So I need this. We don't need much, but we're gonna need a couple of them, maybe 3 of them on top of each other. So like this. So the first one. So this power strip, it's like 16 amps, if you can see it. That's why this cable holder here, clamp, is designed for thicker cables. Oh yeah, I need a better lighter. Probably empty. Waiting for the spring. Yeah, I mean, when I start seeing light at 5 p.m. outside, that's when I wake up sometimes. I know that it's like already close. Okay, then let's put on another one. So probably we'll be able to put on 2. Minus 30. Ooh, cool. We've had like some low temps, but this winter it hasn't been this low. I think like minus 25 we've had for a little bit. But we've had a ton of snow. We've had a ton of snow last months in January and in February. All the snow of the winter like came down in January and February. So okay, now it's going to work. Let's test. Everything got to be tested. I don't want to redo it. Let's see if it keeps it in place. Oops. Stay in there. Okay, you can see the whole assembly here moves when I put like when I try to pull it out, so that's good. So then this supposed to be like it goes here. Good. Okay, for now you stay like this. We gotta cut these two to the length. So how this switch works, if you don't know, so middle position, nothing's connected. Like let's call it like right position, one side's connected, and this position not side connected. And here it is exactly like This is two inputs, let's call it like that. In our case, they're going to be inputs, and these two, and these two, they are outputs. Provolone, no snow this year. Where are you from? If you don't mind me asking, like the area of the world. I don't request any specifics. So, like when it's 0 here, nothing's connected. When it's like 2, oh crap, the camera crapped out itself. Just give me a second. Back, okay. So when it's like in this position 2 here, then the central one's connected to this side. What is wrong with you? Let me try to reconnect the top cam. It's like overheating or something. No, it's actually not even hot. Okay. I reset the cam in OBS. Give me a sec. Activate. Here we go. Do not shake. That's the light I hit with my headphones actually. Okay, so and these two cables, these two wires, they got to go over there. So let's say this one to that side and that one to that side. So let's see what length we really need. It shouldn't be excessive. It shouldn't be too short. So, and this will just click into this hole. That's how I printed this adapter. Oh crap. Let me actually reset the white cam settings. It's not really, yeah, that's the right profile. Every time it disconnects itself, it loses the settings that are actually in the driver of the camera. So yeah, so you push it really hard in there and it goes in the hole and stays in the hole. I don't want really to do it right now because I might not be able to pull it out. So far it's just got to be like this while we are working on it. So maybe I could make it even a little bit longer. Well, these ones I don't need to do, don't need to make them a little bit longer because I can just connect them from here. So I think this length should be kinda enough. I hope. Okay, let's free the cable because it's gonna be very annoying to put crimp connectors on this one like this when it's clamped really tightly in this holder like this. So the cable's out. So these two gonna be of the same length, roughly, not roughly the same, completely. So let's hope I didn't make any mistake. I can maybe add a couple millimeters just moving this cable in a little bit, but yeah, let's hope I'm not going to need it. So, and to save, okay, I didn't think of it. I didn't think of these ones. So these ones, they are a little bit too long. That's the problem with them. They are a tad too long. So, but we can try to just make them less long. See how long they are. So we can make them a little bit shorter and hope it's enough. Crap, this might not work. Maybe I made this part a little bit too small. Maybe it should be even deeper. Crap, because it's like goes here like this, and there's not a lot of room underneath it. See, that's what I'm talking about. Plus we have tops of the capacitors here. It's better not to touch them with any electricity. Crap, that might be a problem. Okay, the result's not guaranteed. Maybe we'll have to just revisit it later when I add like a little bit more to the depth of this button switch holding adapter. Switch holding. Okay, but for now, let's see if I can just make these ones shorter. Still keeping some insulation on them, but this is like, yeah, pretty strange going to be. Not like we need this insulation at all, so, but it's not going to be in the way. Or is it going to be in the way? Yeah, this is not ideal. Like this. I cut it off completely. Now the connector of this the connector here is exposed completely, so this is going to have some live voltage there. That's not good. And actually I don't need the red ones. The red ones are a little bit too wide. It's like for different gauge of cable. Yeah, I need to work with the blue ones. Okay. Yeah, it's a little bit longer, like 1 millimeter longer, but it should be good enough. So like this length of the cable I need to be stripped. I need to strip. So I'm not using any stripper again, because this way I can do it more carefully and more accurately without cutting any strands inside. Let's see. That's perfect, and it's still here, it's still insulated. So, but this might be not really enough. So, okay, that's special clamping device for this specific type of connectors. So it should be like this. I always have problems with just positioning them. Here we go. And it's not going anywhere. I'm pulling it pretty hard now. So now the second one should be roughly the same. Well, roughly the same, just the same. Stripping it carefully, like I'm not even cutting the insulation, I'm just pushing the knife through it vertically, not with cutting movement but with pushing movement. I keep explaining that because people do not really understand how I do it and why I do it that way. Okay, so another small one we need. Let's make it even shorter, which technically you're not supposed to do. It closes, of course, but we open it again with small pliers. The plastic, the insulation plastic of the connector. So this goes like this. This goes like this. That's perfect. Even a little bit longer, but okay. So I'm not sure I'm positioning it 100% right in there. I'm positioning everything in this clamping thingy, but it does work. It stays on. Okay, so we got two. We need to do it 4 more times, but those are going to be a little bit more specific cables. So let's test fit everything again. So you go here like this. I'm going to even clamp it in here properly. Okay, so roughly like this. Then this is supposed to be here, and then let's see if I can put it in. Yes, I can. Okay, that fits, of course. So there's a little bit of distance that can be traveled there if needed, so a little bit of play. This goes like here, staying there, by the way, like this. So this is like half a centimeter out. So let's see if I can then close this. Oh yeah, that's a problem. No, there's a problem somewhere else. No, there's no problem. So I can 100% just push it in, and everything that's connected to the button is going to stay, and maybe some of the insulated wires touch these components here, but it's going to be just them touching the components, nothing else. In insulation, and these are not sharp, so okay, so good enough. Now we need to do our special wiring inside. So how it's going to be: from this side it'll go to the in of the board. So we got to do like Oh, we got to decide with the length of it. Okay. Oh. Oh. Maybe I made sort of a mistake. Just to be able to assemble it, I have to have some length available to me here. So, like this maybe. So, oh yeah, that's gonna be more problematic. So, from one side, how to show it to you? From one side, from this side, hey, from this side, it should go here. From this side, it should go here and here. But then, from here, it should go here and here too. So I think it has to be sort of kind of a little bit of a double cable, a double wire. From out it goes here, and then from here it goes here, because, well, everything connected like in parallel. Okay, so we need them as short as possible, but I should be able to assemble it still. So, and I should be able to hot glue this board down and then connect all the cables. Yeah. Well, these are super convenient that I can actually connect them to the button like that. That's super convenient. Okay, let's see what length I could use. It's going to be like all coiled inside. Can I make them like smaller in any way? Just still able to assemble them. So if I use these cuts, so like from here, then to there, you cannot see it. So, but then the board would be erased when I connect it, and then I move this like this, and the board would go back in its place, and I'd be able to hot glue it. But it's gonna be tight. It's gonna be super tight. Okay, but I'm going to give it a try because we need them as short as possible. So let's start preparing them for soldering and crimping. So, and this is, by the way, with this like with this button, well, no, with the switch that was inside that I removed and made my own adapter for a different type of switch to have more room. This is probably the largest one of this form factor that I could find. Not probably, this is the largest one. Okay. That's one side of it, and another one should be as small as this one, maybe even smaller, because this is just to be soldered in the board. Maybe I'll have to do like another approach on these. Maybe I'll have to make them longer. It's not I'm saving on the wires or anything. I'm just trying to have as less wires inside as possible. Plus, this will have to be pre-soldered, so the insulation will start moving away. Okay. Now let's prepare this one. It's like really millimeters here. Okay, this one a little bit too short for the crimping connector. Okay, this is better. The last step, of course, I do with my teeth. Stripping them. Okay. Let's get the connectors. Okay, let's prepare them. Cut them again. Cut the insulation off of them. Normally, of course, you never should have to do. I'm Sherman Tank. I have no idea. I don't do ASP32. But for my teeth, yeah, well, we are past that. Gonna get you. I have like 11 teeth in my mouth that are not even like mine. Not technically. It never been like living tissue. So I'm Sherman. Welcome to the stream. I don't do that stuff. This is going to be like super not automated. This is going to be super manual, not controlled over any internet connections. I think you are not supposed to have your lights, any like serious appliances connected to the internets. So home automation and all that stuff, I absolutely do not like it, unless you need to be turning on and off your lights when you are not at home. I don't have that need really. So for now. But then this can be modified actually into that too, because this is what sends the signal to turn things on and off. So, and this is just a transmitter. Anything can control this transmitter. So technically anything can press this button. Electronic buttons, electronically of course. So yeah, I don't do electronics on this channel. Probably the most complicated thing that I've done, I designed a relay based latching single press switch, but I've never moved past just building the thing on a breadboard and kind of figuring out with the things as I was going. So I built it on a breadboard, that latching switch. That was more an idea of the switch than something usable actually. But I'm actually working on trying to turn that into proper schematics. But if you'd like do one component on that schematics week, yeah, it takes time. That's the speed I'm working with on that one. I didn't forget about it. Okay, here we have one. So I actually have it somewhere. Where did? Oh no, I'm not having it here. It's gone. No, it's here. Yeah. So several years ago I built it on stream. So this is the latching switch that switches with just one press of the button, but it can have like on button and off button, and those are not going to be switches. These are buttons like one press, another press, or they can be pulses. They can be like voltages coming in, like when 5 volt, for example, would come in, the thing would turn on, and then when those 5 volt just disappear, the thing would turn off. But it can be like, it can have buttons too, so that's why it's so complicated. It can be actually, it can have settings even, that schematics, that thing, it can have settings to react on like incoming 5 volt, on when it's like a front of like it going from 0 to 5, and to react on it going from 5 to 0. So you can turn those things on and off on that board, and you can manually actually do that. Probably a couple days and less in sleep mode. What did you say? About the ESP thing. Yeah. The ESP, actually, Nicola knows way more about that stuff. He's currently working on one thing with ESP. Not 32 though. Not 32. On my request. But maybe the next one's going to be 32. I requested him to program to make, not, it's not really going to be a complicated board. So it's not going to be complicated schematics. It's going to be quite complicated code. But Nicola actually is a good coder. So he coded this thingy here, this device. Crap, can I show? Yeah, this device. And that one I'm using. Look at this. So if you're watching me on Twitch, you heard that. So I'm using it as a DIY Stream Deck, but it's not Stream Deck, it's a MIDI device actually. I forgot to clamp this. So that has a ton of code in it, that thingy. Quite some for a device this small, because it has a screen. Toast, it's called Toast MIDI controller, Toast by Space Melody Lab by Nicola. So it has a screen, and the MIDI settings can be adjusted on the device itself. So more info about that Toast by Space Melody Lab you can find on our website, Space Melody Lab. So my input on that device was like 1%, 99% of the input of 100% of the work. It's like by Nicola on that one. Okay, so we have these ready on one side. Now let's make them ready on another side, and let's see if we solder them, if they even like long enough. So my dirty, I always have a dirty tip. So because I use a lot of flux, that's pine rosin, that thing, when it burns, eventually it gets dirty, but it smells good. Okay, the microphone is a little bit in the face, and it's a little bit too loud to be in my face. I actually changed the settings of the microphone, so you'd be tooltips, yeah, so you'd be able to hear me without the microphone being next to my face. Yeah, that's why I like good wires, and these are good. So Chinese crap, sometimes there's a lot of actually Chinese ones that wouldn't take solder even at all. This one, proper copper, takes solder just in one touch. Properly takes, soaks it pretty much in. So okay, let's see. So this is again just testing. It might not it might not be long enough. It might be, it's not going probably too long, but it might be too short. So in. Oh, there's a fuse on this one. I didn't know that. There's a fuse here. Good to know. I was kind of worried that I'm making such a thing without a fuse, but no, this board has a fuse. Good to know. So this we are going to call, this is going to be then, just judging by the schematics, maybe they consider this being like live, not phase live, whatever, not neutral. And this is like neutral because it's connected to the output. Yeah, okay, doesn't matter, since in here it can be reversed easily because we have reversible wall outlets and reversible plugs for them. Like this. At least inside the device. Let's keep the color coding. If it's brown, then it's live or phase. If it's blue, then it is neutral. And if it's yellow-green, it's ground. But yeah, if you change yellow-green with anything here, you might end up with not just a magic smoke, with a fire. Okay, so we have these two soldered in. Let's see what we just did. So you guys, you're supposed to be like this. So technically the distance is good enough, but is it even? Is it even possible to connect? That's the problem. So what if I like connect it like this? Yeah, that's an issue. Oh, crap. Oh crap. Everything is just moving here. The button fell out of the adapter. So you got to be like this. Yeah. It's not fully on. As good as it gets. Now this side supposed to go here like this. Crap. At least I don't need to solder them. That would have been like a real nightmare to do in this tight environment. Okay, so it's connected, and then it is supposed to be, oh, upside down. Yeah, it's supposed to be like this, so there is still room. Yeah. So then it closes like this, and then this plugs in and clips in like this. So technically speaking, it is working. It's super tight, but it is working. So it's going to have a little bit more cables now, a little bit more wires inside. And these two are going to be the next two are going to be double ones. So let's make them. Just like Hubert J. Farnsworth, these are all the length of the cables that I'm going to use. Is he J though? Oh no, Fry is J. Philip J. Fry. He's Hubert Farnsworth, I don't remember his middle name. So these ones I'm going to use for this. But I'm not building a spaceship like Professor Farnsworth did with his cables. So no, as you can see, it technically does what you can even like open it and still have enough length to do things inside. Yeah, and you might have to, because there's a small button here. This is how you teach the device what switches it should be able to hear. So if I just glue this in place, I might be able to just drill a microscopic hole here to be able just to push it with something thin. Okay, so I like how it's going, but then we have to unplug this. So one. Here we go. So these ones, by the way, you can make it even a little bit tighter. If after a couple of plugging and unplugging they kind of ended up being a little bit loose, you just can tighten them up a little bit. So for this we got to make pretty much the same, start with the same length of cable, but a little bit longer, I think, just a tad longer for the ease of it. So I'm going to make it just a little bit longer. Just a little bit longer. So again, explaining the connection. This goes to this side, and then from there it goes to the outlets themselves, because, well, that's how I see the functionality of the device. So when it's like middle position 0, and you a little bit too loud. Okay, maybe it's not too loud. Maybe it's too loud for me. So middle position, nothing happens, nothing works, nothing. It's completely turned off. In this position, it's like going to be, okay, let's imagine in this position, it's going to be override of everything. It's just on. And again, this board's not receiving any power. And in this position, the board's going to be receiving power and in control of the outlets here. So it's just if this thing gets ruined, if this thing burns or something happens, if it breaks, and I don't have time to just open the whole thing up and fix this or replace it, I would be able to continue using this one just by manually switching it on and off. So here we'll have to do a little bit longer, side for the crimping connectors, because it's gonna be two wires here, not one. I kinda going to create connection between two wires by crimping them both in the connector, which is way better than soldering. Okay, I don't need actually to turn it, to twist it. It's better actually to take two and twist together. So, and this has to be roughly the same, just to have everything looking nice and good. Here we go, roughly the same length. So the other side goes in the board, so these are going to be pretty short and pre-soldered. Here we go, super short. Let's cover them in solder right away. Yeah, the tip is dirty again. So this is not lead-free solder, but since it's not my professional occupation, I do it super rarely, that's not a problem. And what's smoking on the tip? It's actually smoking absolutely healthy. Well, not absolutely healthy, it's like as healthy as maybe a forest fire. Well, I mean, a couple burning, not forest fire, a couple burning like pieces of pine. So it's pine rosin, so that's what's smoking. Not a big deal. It smells good, that's why I like pine rosin. It makes things dirty pretty fast. The tip of the soldering iron is constantly dirty, but it smells good. Like just a fireplace. Sorta. Okay, and another super short one. Yeah, I'm kind of making them even shorter and shorter here. Okay, all the strands are in there. Not that I'm going to need a ton of strands in here, in this cable. So because even these wires are going to be the overkill for the loads. So the weak link in this chain is this device, especially this relay here. It's actually rated, they say on the casing for this device, on the case, it says that it's 10 amp rated. The relay here is rated for 5 amps on like 250 AC, 250 volts AC. So they lied on the enclosure. Okay, this is not as good as the previous one. Let's see if it goes in, if I can fit it in. Yeah, that's the problem. It ended up a little bit too thick. Checking. Okay, it fits. This one. Okay, kind of fits too. Okay, that was just another test. So this is going to be like this. This is going to be here. Then this should go over there to the switch, and then from the switch it should go this side and that side. So let's try to measure these distances. So they are actually different here, as you can see. This connector here is a little bit farther than this one on this side, so they have to be different ones. So from here you would maybe go like this, out a little bit, going around everything, and then like this here. So here we have room. We can have like excessive wire here to like make a small loop, so it's not going to be that much of a problem. So this one cut to the length here, and this one's going to be a tad longer, like this. Let's prepare these cables here, cable wires. So first, on these ends we got to have these metal tubes on them. Because if your connector, or whatever it's called, another like clamping connector, if it has just one bolt in it, yeah, either you got to have a single thick strand, single thick wire that doesn't have strands, or if you have like stranded with the one that consists of strands twisted together, you got to put that metal tube clamped on it. Okay, that's one. Again, I sometimes make mistakes when I try to do things this precisely. So oh crap, almost cut myself. Well, this is a pretty dull knife, to be honest. Okay. Okay, let's do the thing is here. They're sort of kind of color coded, but I think the color on these caps, whatever they are, it's like not the type, but it is the size of it. Okay, crimpers. So these are a little bit too thin ones for this crimper, so I have to do it like several times. Several times, turning the cable, turning the thingy inside the crimpers. Okay, this side's ready, so let's get this out of the way. We don't need them for now. Let's see how deep they would go in. So, pretty much all the way. And on this side, vad grejer här. Thank you for the follow. And on this side, yeah, pretty much completely. This one has a limitation on the length of the cable you can actually wire you can put in. These ones, they seem to be going way deeper. Okay, good. There's like one problem less. Don't need to cut this to any length. So now on this side, let's prepare them on this side. Again, stripping them a little bit more. No, don't need to twist them, because I would twist them with these ones. Twist them together and then clamp. Okay, so now this has to be done like something like this to make them intertwine as good as possible, like this. And then on top of it, we gotta put, this time it's going to be the red one, because it's intended for cables with a little bit larger gauge. No, it's a little bit too large, so still going to use the blue ones. Does it fit? Yeah, it does fit. Okay, we got to again cut off these sides of them just to save on the room inside and allow the cables, the wires inside, to be more flexible. Normally this type of stuff you absolutely won't need to do, but here we are very tight on our tolerances. So, and yeah, I kind of want to add solder to these ones, but technically when you have only 50 watts here and that's going to be no more than that, then yeah, but according to the standards these cannot be soldered. Okay, this is a little bit too long. Let's cut off the tip. Oh yeah, there's like strands everywhere now. So now it's perfect. Okay. It seems to be staying there. Though one of the cables is sticking out a little bit, just like half a millimeter without insulation. Well, that's why you have these sort of covers here on this insulation because, well, that's for that, but I have to cut them. So okay, let's do the second one. Can I twist them a little bit better? Like this. Okay, again, we'll have to cut the tip one way or another. Forgot to prepare the connector. Here we go. Let's clamp it. Okay, so it is in there, not going anywhere. Let's try to assemble it. So first of all, this goes here. Will I be able to solder it without using this, the use of the third hand? Let's see. Sorta. Okay, better. You're welcome, man. Yeah, it's true, but please use English in the chat because this is like super international channel. We have people from all across the world, from even like South Korea and even like from Argentina. So, in order for everybody to understand, please use English. There's not a lot of people. Speaking Russian here. A couple. So yeah, everybody's welcome. Just please use English. Please use English for everybody to understand. So thanks for jumping in, Mando. I normally stream games, but I would do tinkering, like making stuff like this. Wouldn't call it even like assembling. It's just soldering. Very basic things here. It's just nothing really. So, but yeah, mostly on this channel I do gaming. So, okay, so we probably have a problem here, but let's see if we can go and find our way around this problem. So this is supposed to go here. Let's see the order of assembling we need here. So this, for example, we do first. This is actually not tight, I remember it. Then this one we do the second. No, Jack. No. I'm not a console type of guy. I'm not going to. Well, I mean, I won't lie if I say that I've never had a console, portable or not. So I've always been a PC gamer, but I got my first console like a year ago. It's they call Dandy here, but it's a Chinese version of NES. So, but it's pretty special NES because it has a keyboard. Wogre has soldering. Yeah, I see. So this is like super basic soldering, man. Nothing special. Uh, this solder contains, I think it's 31 or 33. So let me see if it's like 31 or 33. Just give me a second. Percentages of lead and tin in it. No. NES with keyboard. Yeah, really. Yeah, that's insane. So I think it's like it's either 31 or 33% of tin, and actually 37 or 38, 39% of lead. So, and as the flux, I use pine rosin. So what's in Russian called kanifol, pine rosin flux, super old stuff. There's even some actually. It's like from the old kit of this soldering iron. So this is even what's it called? Like soldering lard. So yeah, this is an old way of soldering, like super old way of soldering, but still good when you have to solder big things. If it's something smaller, then yeah, it's better to use different stuff. So Jack the Fast, yeah, I'm not really into consoles. Okay, now let's see if we can connect this. So I hope you can see everything here. So this supposed to go here like this. Maybe actually I should remove this wire first, and then put it in just after everything else gets connected. Or modding old Game Boys. Yeah, I'm not sure Game Boys actually were popular here. I'm not sure. Yeah, Chinese NES as Dandy. Yeah, they used to be popular, of course, but that stuff, different markets, different products on them. Okay, I'm curious if I can do it. These are like tight, but they're supposed to be tight because it's 220 volts. It's going to be. So then this one goes here, then this one goes here like this. Oh boy, this feels like it's a little bit too short. I know, got it on, so can see it from here, both connected. Now this one goes here. Okay, connected. Maybe I can give it a little bit more of a push in there. So, and this one, the last one, gets connected too. I got it all connected. So this ended up being a little bit too long. Okay, then we can do it like this. This one ended up being actually just over right size, over right length. IPS screens, the old ones. Yeah, that I've seen, yeah, actually. But you know what? These days you can actually play games on your phone, and pretty good ones. And I never been a fan of mobile gaming. I don't know why. So I never even looked in that direction. So I guess I'm not a mobile gamer at all. Okay, so this is all connected. And this can actually be placed here. And I should be able to just glue it in with hot glue because, well, the length of the wires it's good enough. Okay, let's see if we can close it. Like this. Okay. Something kinda gets in the way, but maybe that's just the excessive length of the cables. Okay, now it's time to click this thing in. Please go in. Not like this, both sides at the same time. Oh yeah. See how it's supposed to be? And then here, maybe if we just route it a little bit the way it's supposed to be bent, like this. So I'm just bending the cables inside, trying to get things out of the way. Fits, but not nicely. Something feels a little bit off there. It's like, yeah. It has to be attached to the bottom of the thingy. It's like it doesn't want to close on one side, really. It's like something gets in the way. And I think this thing here gets in the way. So okay, but we have, at least we have a way. It's like, yeah, this cable too, routing these cables. It's a thing, it's just a thing for this type of power strips. You got to route them. Now it fits nicely. Now it's in there. Okay. Well, it's not programmed, so we got to program it. In order to program it, it's a pretty loud word for this type of it's more like just letting it learn the switch that we are going to use. we gotta actually give it power, but there's a problem with that. No plug. So let me get the plug. It's going to take a little bit of time. So be right back. Okay, I'm back. I found the plug. So I totally forgot that I was going to need one. Oops. Do not fly. So let's put it on the cable then. It's not a big deal, just standard job. This one, it's not the one that would open like a book. The ones that open like books, like left and right sides, they're good, but they tend to break sometimes in the middle where they open. So like this. Interesting. Okay. Never seen this type before, but if you say so. Okay, so wait a second. How it's supposed to be? Like this. It's supposed to go in like this. So then the cable goes in like this and splits immediately after the clamp. So the length would be somewhere along the, okay, here we can cut it a little bit, we can strip it a little bit longer, and then we will cut it if it's a little bit too long, but it's not going to be probably. The music is a little bit too loud. I forgot to make it quieter. But the music, you only can hear the music if you are watching me live on Twitch. If you are watching me on YouTube, if you are watching this as a recorded video or on YouTube or the VOD on Twitch, no music for you. Come on. Okay, let's see if the length is enough. Yeah, sorta, kinda, sorta. Upside down. Yeah, enough. More than enough, I think. Okay. Open the clamps, clamping bolts. By region, so many types. Yeah, really. Yeah, these are called Shuko, I think, European. I don't remember the exact name. Here they call them just European ones. They're actually pretty serious. They're supposed to be very tight, and they can carry a lot of current on 220 volts. So these are not joke. I would easily plug in something consuming like 2000 watts, maybe even 3000 watts with this one. Well, of course the wires should be on par, but these prongs, this type of just outlet, yeah, it can do that. This though is rated only for 16 amps. Max 3600 watts, this one. Well, I mean, of course not this, but only this. So okay, so, and again, we are going to need to put these metal tubes on these ones. You know why? Because when you clamp something with a bolt just coming through and clamping, you cannot clamp multi-stranded wire. It will be crushed. The small strands will be crushed by the bolt. So you got to put a metal shell or casing on them and crimp it on. So, but these are, I believe, the last steps. If this thing doesn't blow up, then we will be done. well, not technically done because I'll have to put the board on a big blob of hot glue inside. But that I'll do off stream because my hot glue gun is like amazingly bad. You just cannot. I won't be able to keep it on my desk while plugged in. It would just try to fall off, pulled by its own cable. And I don't have like outlets on my desk. They are the closest one just under my desk. Surprisingly tight even without clamping. Okay, well, I mean, tight is better than loose. Oh, come on. Here we go. Have to clamp it several times because these are too small for this clamper. It does the job, but sorta kinda on the small ones, not the best job. Visually it's not the best. In fact, well, they stay on. It's not really possible to like remove them after they get clamped. I do it several times with a manual offset. Just to get it, yeah, seated better. So I hope this is enough because this part I actually don't want to redo. Yeah, should be. Let's start doing it then. So, hey, crap. This post kind of gets in the way of the middle one, which is like super annoying. Okay. Let's just tighten the bolts. And the last one. And then this goes here like this, and Are they the same? Oh crap. One's longer, one is shorter. Okay, let's see what we need. Which one we need? The shorter one, the longer one. Oh, the longer ones. Okay. Not exactly a MacBook with different types of screws, where you can just by screwing a long screw into a slot for and a hole for a short one, you could ruin the whole board. So not exactly that situation. Hey, do not move out of the way. Like this, stay. Here we go. Okay, let's see if we can now actually fit it in, which seems to be a tad problematic actually with this design. Yeah, that's not probably the best design. Oh yeah, super. So, not the best design for assembling it. But seems to be good enough. Well, I mean, assembling might be hard, but feels sturdy. That's what I've been trying to tell. Okay. Technically speaking, it is ready to be tested. So this I do not want to close. Actually, we'll have to keep it open because of this button. Okay, first of all, let's turn the music off. Then let me get... Looks legit. Well, I mean, I just realized, people, that I could do it better. I could just wire everything down here and then solder it like this with this board pretty much here. So I could technically do way shorter wires inside. So technically, just by sort of soldering this one on the last one. This is a well, I mean, not really. It's not a prototype. This is going to be deployed. Okay, I need some power here. Let me get some power. Just a second. Yeah, really, I wouldn't trust them though, because it's still 220 volts. So for testing this stuff, I have a strip like this one. It's fused, it has switches, it has ground protection. It's actually like resettable fuse, so okay. Currently the button is off. The packaging yeah, I don't think so. So see more power strips, yeah. So are we ready? So the power is on, and now this one. So now it actually has power, so gotta be careful. It's not on though, so now it is on. Now this board supposed to be on. Now it has electricity going on through it. Yeah, amazing. There's one more thing here. The switch needs a battery. So yeah, it is currently powered. Let's see. We need a battery. Let me get one. The user is supposed to use standard CR2032. Give me a second. So plus, which side up though? Maybe the other way. Ah no, doesn't go the other way. I think it's supposed to make like light. Let me turn off. Is the battery dead or the switch? Let me check. I have a battery tester just for this. Oh, this one's completely dead. It wasn't a new one though. Okay, let's see if the other one that's not new is dead. This one's not. Still has some power in it. Let's see if it's enough for the switch to become operational. Okay, strange. It looks like maybe there's not enough juice in this battery left. Doesn't produce continuous light, only blinks. Okay, whatever. Let's try to program it. So it's currently powered, and I need to press this button without getting a little bit electrocuted by the power. Oh, crap. It has detected it. But the light's just on. There's a small red light. I don't know if you can see it. I think this battery is dead too. This cell is dead. So let me get the one that's not supposed to be dead. Completely fresh one. Oops. Okay. Aha, this is better. Look how it's supposed to work. That's how it's supposed to be. So let's do 1, 2, 3. Now it detected it. Okay, let's wait till the light turns off. Peace on the chain. Good evening. Welcome. Welcome to the stream, and thank you very much for jumping in and raiding. Hope your stream went well. Hope everything is amazing. That battery is the main enemy of science. Yeah. Okay, I didn't program it right, so let's actually reprogram it. I think you're supposed to reset it by, yep, here we go. Thomas Lee, good evening, welcome. Welcome, people. Thank you very much for the raid. So I programmed it again. Aha. So it feels like I keep programming it as a. So this currently is programmed as. What's it called? The ring button. It works while I keep the button down. That's not what we need. So let's reset it. Okay. Okay, no. 1, 2, like this. Here we go. Got detected. Let's see what was this programming. Aha, that's on and off. Okay, I think I need to show you it using. Just give me a second. I need a light, and I'm just looking for one that I can borrow. Ah, yeah, of course. So this is exactly what we are using for these plants. So okay, gotta be careful. It's all powered here. This is all like pretty much 220 volts there. So oh crap. Go in. Oh crap. Okay, turning everything off. These are a little bit tight because they are new. Just give me a sec. Super tight, I would say. Here we go. So now it's on. This thing is on. Let's see if I... Yep. I'm going to turn the light off. So this is the mode of when one button just turns it on and turns it off. So it is working. We actually never tested if it works in bypass mode. So this, it's off, but this is the bypass mode. The board's off, but the light, as you can see, is coming through. Well, the electricity is coming through. So like this. Off, wireless switch, off, this switch. So that's like for bypassing and for turning the board off, the whole thing off. Okay, let's again reprogram it because that's not the way I want it to be. So again, even considering that this board spent quite some time without power, it has memory. So still does work. Okay, let's reset it again. Okay, now let's try to program it the different way. So a switch like this is going to be in every room. These strips, there's going to be like 5 of them, I think. And switch in every room would be able to turn them all on, all in the whole apartment, all 5 of them. Then the first one, the second one would turn them all off in the whole apartment, all 5 of them. That's just one. And this one will turn the ones and turn off and turn on the ones that are in one room with it. So so now this program to be one button off and on, off. Okay, now 1, 2, 3. And now these ones are on and off. On and nothing happens, and off and nothing happens. Again, let me show you again. So this is like the basic logic of these devices, if you can see it without the light. So let's actually add some light. So I just took the board out of this wireless switch, as it's called. Standard frequency, by the way, for this device is 433.92 megahertz. That's standard. So here we go. It does work. On, off, or on, off, on, off. So there's gonna be like 5 of them, but I think three of these ones, because we have basically 3 rooms. So there's no need to have each one for every zone. There would be like each one for the room. It is working. It is working, people. Okay, some music back. So now let's try to screw it all together. Just to see if it actually can be screwed together. Okay, it has some caps that can be unpleasant if I touch them. though they are not really that big, but still. So got to be careful with the caps. I recently actually got shocked by a cap in a small power supply. That was unpleasant indeed. After the power supply was turned off, of course, completely. Okay. So it's supposed to be like this. That's the device we've been working on. So, and this adapter, this thing here that I designed is 3D printed just to the size of this hole for a standard switch that this power strip comes with. Just to be able to use different switch and just to be able to have the room inside for the board and cables. So kind of move the switch out of the device. So let's see. I'm not going to try to completely screw it all together. I'm just going to put one screw in to see if it... Well, yeah, it looks like a pretty normal power strip, just by Makel. Just a little bit modified. Here we go. So I arbitrarily put 4 amps in there because the relay on the board is rated for 5 amps, but in fact this is going to be half an amp. Maybe it's on 220 volts, 230 volts, it's going to be like half an amp or maybe 1/4 of an amp. So yeah. So it's not really for extension, it's not really for, well, it's for supplying with wall power a bunch of lights like this. So we use these lights for the plants. My wife uses these lights for the plants, and we have like a ton of them and similar ones. So they're pretty easy. They can be wall mounted, they have a hole, and they can be, of course, clamped onto something. They have this clamp, and they can be repurposed for anything. They're universal. So it's not that just okay. This is like success. But I spent thinking about it. I spent thinking through the whole construction, not construction, the whole design of it. I spent quite some time thinking about it, thinking how to make it. And even like we built the first one, maybe there's a way to put even less wires inside. So there's like kind of a little bit of a spaghetti in there, spaghetti mess in there. But yeah, so what's left is to open it, use some hot glue to keep the board in place, which I will do just off stream, and the first one's ready. So I ordered these button adapters, a bunch of them for printing. So I have a bunch of them. I actually don't really have a lot of the wireless switchboards, so I will have to order a couple more. I think I have 3 and I'm going to need 2 more. So, and the switches, I think I have enough of them, like 3 only. Okay. So thank you very much for watching, everybody. This is going to be it for tonight. Let me just readjust the microphone back. So this is going to be it for tonight. Total success. Again, just to say it in the beginning, if things somewhere go smooth and work from the first attempt, it's because I had spent already quite some time thinking about it and designing it. If it's like, if something breaks, it's because I actually didn't spend enough time thinking about it. So again, thank you very much for watching. Thomas Lee, thank you for your follow. Peace on the Chain, huge shout out for the raid. Peace on the Chain is a nice people. They are nice people playing DZ. Let me actually do a shout out if I remember how even to do it. To Peace on the Chain. Here we go. Just give me a second. So if you are into DZ, take a look at Peace on the Chain's channel. Just like me, I'm into DZ. Vogrehe, I suppose that would be. Thank you for the follow. And if I missed somebody, my apologies. I kind of been a little bit busy working on this thing. So thank you very much for watching. Don't leave the channel yet, please, because we got to find somebody to rate as we always do. But first, YouTube people, thank you for watching on YouTube. Please leave a like if you like this video. It's not a guide, it's not a tutorial, it's just how I made this thing. So if you want to make your own, you at least know where to start. But for you, it's gonna be different, simply because even different parts of the world, they have different like wall outlets, different plugs, different wall outlets, and yeah, things like that. Subscribe for more, as I said. Don't forget to activate notifications to catch me online, because even though I stream every day, and I try to do it when it's nighttime in Europe, things can be different here. Twitch people, thank you for watching on Twitch. Let's see who we can raid tonight. Again, I say thank you to all the new followers and raiders and viewers. Thank you, people. Was nice to see some old faces. Well, the faces, not old faces, that I haven't seen in a while. And oh god, that's in the headphones. Somebody talking. So, and some people that's like new. So thank you very much. Now give me a second. I'm going to find somebody to raid. Her calling old. Yeah, not old, just wrinkly. Not old, just wrinkly. So I raided this guy. Okay, if you give me a second, maybe we could find somebody. Somebody doing something in science and technology section, but that's hard. Because there's a lot of automated streams in science and technology, not a lot of tinkerers these days. Not a lot of really live streams with people. A bunch of automated streams, some recorded stuff. That's annoying. Actually, it's kind of annoying that you cannot see like live people, real life people in the section. Is this live? Can I read them? Wogre here, I know, right? Yeah. And there's like not a lot of, well, I mean, it's not really the right time, to be honest. It's kind of late even for the States, I think. Well, not really, but it's definitely super late for Europe. Okay, let's see. Yes, we can rate the streamer. Let's go and say hi to Lake Spooky. They are working on a freaking plane. Fuselage of a plane. That's big, yeah, that's big. That's what it sounds like. So thank you very much for watching. I will see you all tomorrow. That's it for tonight. Goodbye and good night. And yeah, huge thank you again for keeping me company and even helping me with this small build. And I'll have to build for more of this, so that's gonna happen on stream too one day. Goodbye and good night.